Hello and welcome to a special interview for The Wire supported by Glenlivet Books. My guest today is the director of the highly regarded South African Institute, whose laboratory tests have shown that Omicron can create a 40-fold reduction in neutralizing antibodies after 2 doses of the Pfizer vaccination. Joining me now to explain those results and also their implications is the director of the Africa Health Research Institute at KwaZulu-Natal, Professor Willem Hanekom. Professor Hanekom, as I said in that introduction, your institute did laboratory studies which have shown that Omicron can create a 41.4-fold reduction in neutralizing antibodies after 2 doses of the Pfizer vaccine in people who have not had a previous infection. Now, for laymen, that sounds like a huge reduction. So can I start by asking, does that mean that Omicron almost completely evades antibodies?
That is what you would presume, but it's actually not the case. So if you look at the results very carefully, Omicron is still having the antibodies from people who were vaccinated by the Pfizer vaccine still has some activity against the Omicron. It's just that the activity is significantly reduced if you compare it to the antibody activity against earlier viruses that emerged during the coronavirus pandemic. So there's definitely a massive drop in the ability of the antibodies to control this virus, this Omicron in a test tube, but it's not completely obliterated. It's also important to understand that when one does vaccinations, such as using the Pfizer vaccine or the AstraZeneca vaccine, the vaccines induce or cause many of the arms of the immune systems to be activated. And antibodies is just one of those arms. It's a very important arm, okay? And therefore, these results are concerning. But there may be other arms, such as T cells, for example, that may compensate for that and actually still induce protection.
I'll come to what's called cellular immunity, T cells and B cells in a moment's time. But another part of your study has established that in the case of people who've had 2 doses of Pfizer, but also a previous infection, the antibody response remains considerably stronger. Just for clarification for the audience, in their case, how much is the antibody reduced?
I think the antibodies are reduced. It's not really the antibodies that are reduced, but the activity of the antibody that's reduced. And the activity is reduced as much as, percentage-wise as it is for people who only received the vaccine. It's just that we've known this for quite a while, that if you've had disease and then get a vaccine, you have a much higher antibody response to start off with. So if you then have a reduction in the amount of antibody effector function, that there's still likely to be much greater effector function than, for example, if you had the vaccine only.
That's a very important answer you've given, and I'm just clarifying it for the audience, and correct me if I've done it wrongly. You're saying that, in fact, the reduction in the antibody response for people who've had 2 doses of Pfizer and a previous infection is the same as the reduction for people who've only had the vaccine but not a previous infection. It's just that people who've had the previous infection would have a much higher level of antibodies, and so they still have a lot left. But the percentage of reduction is the same in either case.
Correct. And we think that the antibody effect is very much a quantitative effect. That means the more you have, the better. All right. And that's, for example, why additional dosages of the vaccine may also work, because it will induce even higher responses. So if you start with a higher response and you have that reduction in activity, you still have quite a bit of activity left.
Now, I gather that the study done by your institute is based upon 14 samples from 12 people. I'm not being skeptical, but audiences will want to know, how confident are you of this outcome?
You are absolutely right to be skeptical. That is the way to think. So we need much larger sample sizes for these kinds of studies. Now, we actually at the Africa Health Research Institute are following 600 participants already who either got vaccinated or diseased. So we're increasing the numbers right now. We're also extending the studies to persons who received the other vaccine that's available in South Africa, which is the J&J vaccine. But I must tell you that when one looks at what is the right sample size to use in research such as this, it really depends on how dramatic the effect is that we see. And if the effect is as dramatic as we've seen it so far, it's pretty clear with only very short, small sample size. I also have to add that since Alex Segal, who was the professor in our group that did these studies, since he released this 3 nights ago, there are 3 other groups globally that have released similar results. They use the same kind of lab test. It's called a neutralization assay. They may have slightly different conditions, but all of them came to the same conclusion, that there is this pretty dramatic drop in the ability of the antibodies to control Omicron in the test tube. So I think we've got additional data from all over the world that sort of confirms that this is really a true effect.
Absolutely. And for the sake of the audience, I'll mention those other institutes that have done similar work showing similar results are the Karolinska Institute in Sweden, the University of Frankfurt, and I believe Pfizer itself has produced results that have very much the same outcome as well. Now, to come to the point you were making about cellular immunity, as you correctly pointed out, antibodies are only part of the protection that vaccines give. Many believe that the more important half of the protection comes from cellular immunity, T cells and B cells. Do you have any sense of whether Omicron would adversely affect cellular immunity?
Once again, a brilliant question. And that is exactly what we are looking at in South Africa right now. In South Africa, we've got a national variant research consortium. I co-chair that with Tulio de Oliveira, and we've got various groups looking at different aspects. And so we've got a very active T and B cell group. And this group has already done what we call in silico prediction, where you actually, by just looking at the virus and using computer algorithms, you can actually predict whether the T cells are still going to be able to recognize the virus and have its responses. So these are early days. Again, these are predictions, and the predictions show that there are quite a few of these T cell responses that are not likely to work, but there are quite a few of them that are likely to work. But the real thing that has to be done is lab tests to actually confirm that. And Professor Wendy Burgers at the University of Cape Town is at the moment busy doing those experiments.
Now, this is again very important. You're doing computer algorithms, and they are showing that quite a few T cell responses won't work, but equally quite a few will. The audiences will ask themselves, of the T cell responses that won't work, are they the more important ones?
You ask all the right questions, and I unfortunately have to answer quite emphatically, I don't know. I don't think we've deciphered to that extent to know exactly which of these T cell responses are the important ones.
I understand. Now, your study was limited to testing the impact of Omicron on Pfizer. Do you have any idea of what the impact of Omicron on AstraZeneca would be? AstraZeneca in India is called Covisheild, and I ask because 90% of the vaccines given in India are AstraZeneca. So this is a critical question for the audience listening to you.
Yeah, and I think we have some results already, not from our group, but from the other results that you mentioned that have been done. One of the groups looked at this very vaccine, and using, again, like Alex did in our group, they took blood from people who got AstraZeneca vaccine in this case, and they looked at the ability of those antibodies to control Omicron in a test tube. And they also showed very dramatic reductions in this ability if you compare it to the ability of these antibodies to protect it against earlier viruses that emerged in the coronavirus pandemic. So it appears to be the same. the same kind of pattern. And although more and more results will emerge, I'm absolutely sure that it's a quantitative antibody issue rather than which vaccine was actually used.
So in a nutshell, what you're saying is, and you're now relying upon similar research done by other institutes, not yours. They've been working on the impact of Omicron and AstraZeneca, and it appears that the level of reduction of neutralizing antibodies is roughly the same. In other words, it seems no matter which vaccine you're testing with, one of the effects of Omicron is that it very substantially reduces neutralizing antibodies.
That's correct. Neutralizing antibody effects are really reduced.
Now, yesterday, the South African Health Authority authorized boosters for every adult over the age of 18, provided 6 months have passed since they had the second dose of their vaccine. Do you think something similar should be followed by every country where Omicron has now appeared?
Yeah, that is perhaps virtually every country in the world. As you know, that Omicron is now in more than 60 countries. So I think it's best to follow the WHO guidelines. And the WHO has a very good system to look at what's happening globally and make guidelines for countries. But you're absolutely right. It seems like that the right vaccination schedule for the Pfizer vaccine is 0, 1 month, and 6 months, or 0, 1 month, and 7 months. That's how the South African authorities will use it from here onwards. And they're very good data now. Before Omicron actually emerged from Israel, this was released 2 days ago, where they showed that 3 dosages of Pfizer vaccine was 95% effective in preventing disease. Now, you know that the reason why we give vaccines is not necessarily to prevent disease or infection. We want to prevent severe disease and death. And that's why we give vaccines. And regardless of all this talk, we all believe as vaccinologists that the vaccine will still prevent severe, even 2 dosages would still prevent severe disease and death in the face of Omicron.
Can I pick up on something you said? You began by saying that the world should follow the guidelines laid down by the World Health Organization. And the WHO has repeatedly warned against, in fact, very strongly advised against giving boosters, particularly while large parts of the world, Africa in particular, haven't even had 1 jab. But I noticed that South Africa has gone against the WHO position and actually now advocated and advised boosters for everyone over 18. I'm just pointing that out. Is that because South Africa is particularly worried about the spread of Omicron?
I think yes, of course, we are worried. We're very worried about this, and we want to do what's absolutely best for our populations. I know that the WHO has had these conversations about boosters. The WHO has to play a very, very intricate a game, in that there are massive amounts of people in the world that still haven't received the first dose of their vaccines. You know that in the world, on average, about 100 vaccines have been given per 100 people. But in Africa, it's 17 per 100 people. And so there are massive amounts of people that are unvaccinated. And if one wants to look at control of this epidemic, one has to look at it from a global perspective.
Absolutely.
No one in India or no one in the United States is going to be protected until people in Africa are also protected, because as long as there's virus circulating, there's a potential for new variants such as Omicron to emerge. So I think that's what the WHO is very concerned about, is that they want people to be protected. They know that the third doses can be more protective. However, they also want to make sure that people start getting protection in areas where they haven't received this.
Absolutely. And I'll underline your point by simply saying that only 11% of the entire continent of Africa have had 1 jab, And just over 7%, I think it's 7.5, have had two. And that is the lowest rate of vaccination anywhere in the world. But let me, before I end, talk about the way in which Omicron, the variant, is actually spreading. I noticed that South Africa is detecting something like 20,000 cases of COVID-19 each day. Is that mainly or substantially Omicron, or is it hard to say?
No, we're pretty confident that more than 95% of this is Omicron. And the reason why we know is because in the diagnostic tests, in the PCR that we use to diagnose Omicron, we know that there's what's called an S gene target failure. Okay, that's a big word, but what it basically means is that this test to diagnose COVID-19 in you targets two parts of the virus, okay, not just one part. And the one part still comes up, but the other part doesn't come up when it's Omicron because that part has changed in the virus. So we can track actually what's happening in the country by just looking at the diagnostic tests. And all over the country, in each province, more than 95% of the cases have this S gene target failure. So it means that more than 95% of the cases in South Africa are Omicron.
In which case, Professor Hanekom, if 95% of the daily 20,000 cases is Omicron, do you have any sense of how much more transmissible Omicron is compared to Delta? I noticed that a Japanese researcher, Hiroshi Nishiura, has said that he has done tests which show it's 4.2 times more transmissible. But you're actually in the area where, in fact, it's spreading. So I think this is a question better asked of you. Can you give me some sense of how much more transmittable Omicron is compared to Delta?
Well, I want to tell you that there are mathematical modelers that jump on this kind of data, probably like the Japanese investigator that you've just mentioned. And it's all over Twitter, all kinds of models of how much more transmissible this may be. Perhaps I'll simplify this completely by comparing the 4 waves that we've had in South Africa. We've just entered the 4th wave. And if you just look at the slope in which the wave increases at the beginning, the slope now is much steeper than it was after the Beta variant and after the Delta variant, in the last 2 waves that we've had. So just that indicates to you that this virus is spreading much faster and is likely, therefore, to hold true to what we knew from the genetic code when we looked at it, that it's likely to be much more infectious and therefore able to transmit much better.
One more question about Omicron's transmissibility. Are you particularly concerned about its intrinsic transmissibility, i.e. the intrinsic transmissibility of the variant? Or are you more concerned by results shown, I think, by one of your colleagues, Juliet Pulliam, that Omicron can cause reinfections 3 times more than Beta and Delta? Which is the greater concern?
I think there are 3 things that one should be concerned about. The first is infectiousness and transmissibility, which is the question that you just asked. And clearly, we need to be concerned about. So even if the virus may not cause as bad disease as some of the other variants may have caused, if you have a virus that's very transmissible, it will be a massive epidemic and we will still have quite a lot of severe disease regardless. And the second thing is whether it escapes the immune response. And we've just talked about vaccines and how it may escape some of the immune response from vaccines, but it may also escape some of the immune response from previous infection that's supposed to protect you against a reinfection, such as Juliet has shown. So that is the second thing. The third thing that we really should be caring about is how severe is the disease. And the first indications, and I must say these are early days, but the first indications from 3 massive epidemiology groups in South Africa that have massive studies ongoing are are that the disease is less severe in the majority of case states, and especially in people who've had the vaccine before. So if these people escape the immunity and they still get the disease, it appears to be relatively mild disease.
Just on that particular point about the severity of the disease, I imagine the 3 epidemiological groups that you're talking about have been monitoring the progress of the disease during the first 2-3 weeks of infection. And I noticed that the South African Medical Council a couple of days ago produced a paper, but I believe it's not peer-reviewed as yet, which shows that the majority of people in hospital are quite happily surviving with room air. They don't need oxygen supplements or ventilators. And both of those are clearly a source of good news. But am I right in saying all of this is based upon the first 2-3 weeks of infection? And do we need to watch for another week or 10 days to see if mild disease gives way to more severe disease in the next week? Or is that no longer necessary?
Yeah, so very good question. In our research consortium that I just mentioned, all these groups are present, and they have presented updated data from the data that you've just mentioned that had already been published online. And the way these investigators actually analyze their results is by comparing the first 2 weeks of this wave with the first 2 weeks of previous waves, so that one can have a comparator and not just talk out of the blue of what one is seeing. And if one uses that comparator, it appears that the disease is less severe at this stage. However, I think we need to be very careful here. There were also trends early in the previous waves that in the end didn't hold true when it came to clinical disease. So we need much more data. We probably will have much more reliable data in a week or 2.
We're coming to the end of this interview, Professor Hanekom, but let me put this to you. If it does turn out that Omicron is more transmissible, but the disease it causes is less severe, could we be moving towards some sort of endemicity, a situation which is a lot easier for the world to live with?
Yeah, may I, before I answer that, first say that less severe disease is not a reason not to get vaccinated. We still cannot preclude that people would get severe disease and even die from this variant. So the answer to Omicron is to get vaccinated. But I think you're absolutely right. That's what we anticipate will happen with this coronavirus. It will become the 5th coronavirus that is endemic and that causes colds every season in a seasonal basis and changes every season quite dramatically. And that's why we don't have coronavirus vaccines, for example, against these common colds. So it appears that it's moving in that direction. I think a lot of people believe that this viral evolution, which viruses are like us, we adapt to our environments. We just want to live as happily as we possibly can. And how they adapt is making sure that they can spread, that they can survive. And it may not be in their advantage to kill people, but just for people to be fine and to spread the virus so that they can live happily ever after on this earth. So this is a move from I think ultimately we'll have a move from an epidemic situation such as what we have now to an endemic situation. And in these endemic situations, there's every now and then there's an outbreak again of these viruses.
I don't want to put it any more strongly, but there is a glimmer of hope. If, and there are several ifs there, what you're saying happens, it could then transpire paradoxically that Omicron, which was initially frightening the world, could turn out to be a blessing in disguise. It could be a evolutionary stage of the evolution of the virus where it becomes more transmissible but less severe. It overtakes Delta, but the disease it causes is not particularly frightening. And although we need to be vaccinated, it's a much better stage than the Delta or the Beta or the Alpha stage.
Absolutely correct. But my issue with these arguments at this stage of the epidemic is that I still encounter many people who are vaccine hesitant. And I've encountered in the last 2 weeks a vaccine hesitant persons that have jumped on this message that it's milder disease. And at this stage, unfortunately, although we hope that Omicron is going to cause milder disease in most, it's clearly still causing severe disease. And although we don't have the direct evidence yet, deaths also. So we still need to vaccinate and try and protect us against this.
Absolutely, Professor Hanekom. If people don't get vaccinated, they are creating the opportunity for this virus to mutate yet again and again. And the next mutation could be terribly virulent. There's no guarantee it will be another weak and mild one. So your message is taken. There is a certain amount of hesitancy in my own country as well. We vaccinated 85% of the adult population with one jab, but the percentage that have only got two is roughly 55, much lower, and they need to go forward and get it. But my very, very last question. Newspapers are reporting that Omicron has given birth to two lineages. They're apparently called BA1 and BA2. Are they worrying, or could it be like the Delta lineages, they won't be of any major consequence?
So far, it's not of any major consequence. Okay, the issue is just that the second lineage we cannot detect with this so-called S gene target failure that I mentioned, because that target is still being seen by the diagnostic test. So at the moment, there doesn't seem to be any consequences to this further lineage differentiation.
Professor Hanekom, thank you very much for this interview, for the time that you spared, and for the careful manner in which you have clarified things for the audience in India. Thank you very much indeed. Take care, and congratulations on the fantastic work your institute is doing. Stay safe.
Thank you very much, and you stay safe too.